two lines of regression are given and we have to decide which one is y on x and which one is x on y. The process I am telling you that you have to follow for deciding which one is y on x and which one is x on y. You assume, suppose two equations are given, first and second. First, make an assumption. Assume equation 1 is representing y on x. So what I have to do? I have to make y as subject. 10y is going to be 8x plus 66. So y is going to be 8 by 10 x plus 66 by 10. According to our assumption, byx is going to be 8 by 10. I earlier told you that for finding by on x, you make the equation as in the format you used to do y is equal to mx plus c, that is equivalent to y is equal to byx x plus c. So how to find byx? That is the coefficient of x. Very much clear now? I am assuming the second equation to be x on y. So I have to make x as subject. It is going to be 40x is equal to 18y plus 214. So x is coming out to be 18 by 40 y plus 214 by 40. Is it? So same principle apply here. For finding bx on y, the equation is in the form of x is equal to my plus c, which can be taken in regression line as x is equal to bxy into y plus c. So coefficient of y is going to be bx on y. So bx on y here is 18 by 40. Now I have to decide whether our assumption is correct or wrong. For that I got a tool, the relation of regression coefficient with the correlation coefficient, that is r square is equal to bxy into byx. So I am finding here bxy is 18 by 40 and this is 8 by 10. So if I go for some cancellation, 4 10s are, 4 2s are, 2 5s are, then 2 9s are, 2 5s are. What is that? 9 by 25. So r is coming out to be 3 by 5. So what observation we are making here, that r coefficient of correlation is smaller than 1. We know that coefficient of correlation is always between -1 and 1. If r is coming in between -1 and 1, our assumption is okay. So in actual, first equation is representing y on x and second equation is representing x on y. If somehow we are getting the value of r bigger than 1, then our assumption is wrong and we have to reciprocate our observation. That means we have to make it as x on y and another thing as y on x. This is the technique you follow and decide which is y on x and which is x on y. Why it is important to decide which is x on y and which is y on x is, suppose you have to find the value of y. Y is what? When x is something. Which equation you need to find the value of y? Only y on x will be used to find the value of y. So the importance of y on x is that to find the value of y, we need that equation. So when x is 3, we will get y is equal to 8 by 10 into 3 plus 66 by 10. We cannot put the value of x here and get value of y. That will be irrelevant. This equation is used to find the value of x when y is given. Suppose it is given 2 or anything. We have to make the prediction. We can get the value from here. So you got the importance in which condition x on y is used and in which condition y on x is used. Furthermore, how can we get the mean of two variables x and y with the help of the two regression equations? Solve them simultaneously. Solve simultaneously and get value of x and y. This value of x is going to be x bar, that is mean of x, and value of y is going to be y bar. So easily you can get the value of mean of x and y by simultaneous solving. Another thing I am telling you, one formula, Byx is equal to, very easy to remember, r sigma y by sigma x. This is standard deviation of y and this is standard deviation of x. Suppose you know this, you know this, you know this, you can find this very easily. Furthermore, you know that variance is square of SD. Sometime variance is given. Suppose variance is given 25. What will be ST? ST will be 5. So you can make use of this equation to get the value of any unknown variable if other variables are known. Okay.